Ah, space. The final frontier, as someone said, or something or other. For countless generations, we've been staring up at the night sky, thinking maybe one day we'll spread out, explore, and conquer the galaxy. But until then, we're stuck here on Earth, our small, rocky, watery home. It's home. It's safe. Nothing bad can happen. What's that? Wait, hang on a second. Yep, that's right. Space is trying to kill us. As long as we've been staring up into the night sky, we've also been worried about what might be actually coming down, mainly asteroids and to a lesser degree, comets. So much so that it is everywhere now in pop culture. Books, films, TV. But where did this idea actually come from? What is the reality of one of these impact events compared to Hollywood? And if it did happen, would we actually be able to do anything about it? Modern pop culture is obsessed with the idea that one day an asteroid or comet is going to smash into Earth and wipe us all out. Untold destruction, extinction, blah blah blah, world-ending stuff. But this isn't just a recent thing. One of the earliest examples actually comes from the author H.G. Wells and his book The Star, published in 1897. In this story, a star enters the solar system, collides with Neptune, and the debris heads towards Earth, causing chaos. Now, the star itself doesn't actually hit Earth, but its proximity causes massive destruction and panic. So, not quite Armageddon, but we are getting there. So, let's jump a little bit forward. It's 1910. Halley's Comet is set to pass by Earth, and Earth is set to travel through the comet's tail. Scientists, however, discovered the tail contained cyanogen gas, which is closely related to cyanide. And naturally, everyone thought, that's it, we're all gonna die. Mass panic and hysteria gripped the world. People genuinely thought the atmosphere was going to be poisonous to them. However, as you can tell, that didn't happen. The Earth passed through the tail completely fine. But this event inspired one of the first asteroid disaster films, the Danish film Verdes Undergang in 1916. The title roughly translates to The End of the World. Yeah, I know, very nice and very optimistic. This is also possibly where the I'm having a cheerful title for my disaster film also started. Directed by August Blom, it's one of the first films to show an asteroid hitting Earth and what the ramifications for humanity might actually be. And just like that, it also birthed a brand new genre of film, the apocalypse genre. However, the entertainment industry being what it is, has steadily increased and left logic behind in what an actual impact event would look like. So let's try and make our own and see what that would look like. So we've seen the initial starts of where pop culture has picked up the idea and fascination with impact events. Now, Hollywood and certain movie genres like to run it a little bit too far, so let's try and put an accurate example together of, let's say, a city-destroying asteroid impact. For this example, we're going to be using this asteroid. It's 500 meters across, a density of roughly 3,000 kilogram per cubic meters, and it will be traveling at roughly 17 kilometers per second. And for absolutely no reason at all, I've picked London as the target, because nobody would miss that place at all. Ready, go! The asteroid enters the Earth's atmosphere. Friction heats it up as it travels down, turning it into a massive fireball, and then impact. In an instant, it releases a blast, roughly about 6,000 megatons of TNT's worth. For comparison, Hiroshima was about 0.015 megatons. A fireball over 12 kilometers wide engulfs the city. It's visible as far as the Netherlands. Everything inside is instantly vaporized. Further out, up to around about 50 kilometers, people experience intense thermal radiation. Buildings catch fire, windows shatter, even clothing can ignite. Shockwaves are felt across the country, even into parts as far as Germany and Scotland. Debris is thrown over 100 kilometers away. When everything settles, what exactly are we left with though? A crater nearly 8 kilometers wide, and over 500 metres deep. The centre of London is practically gone. As you can see, not much is left. Millions have died and millions of more are injured. It's one of the worst natural disasters we would ever face. But let's stop a second here. This example is if people just sat around and did nothing. But lucky for us, we live on a planet where there are a lot of smart scientists, engineers that are ready to actually do something. Now, I've shown you a depiction of how horrible something like this could be. But let's be honest, we need to add in the human factor, because people aren't just going to sit around and do nothing. But to do this, we need to rewind a bit. Oh, no, we've got to go a little bit further back here. Yeah, when we add the human stuff in, we've got to go a lot further back. Back it up a little bit. Okay, this is taking a little bit too long. I'm just going to fast forward it. Give me a second. Yeah, that'll be fine. Welcome to the asteroid belt between Mars and Jupiter, if you'd like to know. And there's our asteroid. And, yep, there it goes. Knocked out of orbit. So, countdown begins. But whereas with our example last time, there are people ready to go. Within hours, global systems kick in. The International Asteroid Warning Network, the IAWN, a planetary defense network made up of organisations from across the world, start tracking it. They monitor what we call near-Earth objects, or NEOs. Anything that could pose a threat to Earth is scanned and tracked. Information is shared between agencies like NASA, the European Space Agencies, the Chinese Space Agency, and many others worldwide. Once it's confirmed as a potential threat, governments are notified, meetings begin, and plans start to be formulated. Right, you're going to have to stick with me here a little bit, because it's going to get a little bit weird, because this is where reality differs massively from films and Hollywood. Because usually they like to show stuff taking like a couple of days, when in actual fact this sort of thing can take over months and years. Because one thing that Hollywood tries but doesn't really get across is that space is big! Now, an asteroid can be heading towards Earth but not seen as a potential threat. Most asteroids actually end up just burning up in the atmosphere in very pretty meteorite showers. There is the odd occasion where they are big enough, like ours, to actually cause some damage. And if it's deemed dangerous enough, we start to look at deflection. Something like the DART system that NASA launched with the ESA a couple of years ago. A spacecraft designed to impact an asteroid and slightly change its trajectory, because that slight, as mentioned earlier, space is big, so slight is a lot. Now, DART itself took around 4 to 5 years to develop, but in a real global emergency, with multiple countries probably working together, that timeline could realistically come down. So instead of one country rushing a solution, you've got a multinational conglomerate coordinating global efforts. A small nudge early enough and it misses Earth completely. London is saved, probably for the best, I guess. But let's say it doesn't work. It doesn't nudge it enough. Well, we're not exactly stuck, because humans have the ability to move. Granted, begrudgingly, we can evacuate, one of our old and tested methods. Using simulations and impact modelling, we can predict where the asteroid will hit, how far the damage will spread, and which areas need to be evacuated. It wouldn't be chaos. It would be controlled, planned, and very, very serious. Now, if this hasn't completely reassured you, that's fair enough. Didn't entirely reassure me either. But here's the good news. We are getting better. DART was just the first initial successful attempt. Agencies like NASA, the ESA, the Chinese Space Agency, and many others around the world are developing new detection and deflection systems. For example, there's NEOMIR, a proposed infrared telescope designed to detect asteroids as small as 20 meters, especially ones coming from the direction of the Sun, which currently is a bit of a blind spot. This is planned for the 2030s. Then there's the ion beam deflection, and if your mind instantly went, ion beam. That sounds like something out of sci-fi. Star Wars, Death Star. Let's build a Death Star. It's unfortunately not that. I also had my hopes up, but it's a little bit more science and less sci-fi. Basically, it's firing a stream of charged particles at an asteroid over a period of time. The repeated collision of these charged particles into the asteroid slowly, very slowly, push it off course. It's slow, but deemed to be effective. And of course, there is always the nuclear option. Because of course there is, you know. Detonating a nuclear device near an asteroid could, in theory, push it off course. But it could also make things much worse. So, if we do go down that path, maybe not make it plan A. And there you go. Kind of a bit speculative towards the end, but be assured that there are people constantly researching and developing new technologies, and when they're not doing that, they're keeping an eye on the night sky, making sure nothing is heading towards our way that we should be too worried about. And anyway, the chance of us being actually hit by an asteroid is very slim, even if it is something that is remotely dangerous. So what does that mean? Well, it means that maybe by the end of all of this, we are going to reach those goals of conquering the galaxy, and maybe even reach, I don't know, NASA and Elon's dream of colonising Mars. So then again, we could run into an alien civilization that is not super friendly, but aliens aren't real. So I would personally not worry about something like that. What the chuff is that?